question 13a. It says, in the diagram, ABT is a circle with center O, as this is a circle we'll see with the center O. PQ is a tangent to the circle at T. This is a tangent at T. It hits the circle at T. And ABC is a straight line. ABC, this is a straight line. TC, that's this line TC, bisects angle BTQ. That's at T to B and to Q. The line in the middle, that's TC bisects it. That means divide it into two equal parts. So let's mark that. This and this are the same. So if this is X, this is X. That's what it's saying. Whatever the value of this is also it. Now, angle BAT at A is 44. At A to B to T, this angle is 44. And angle PTA is 60 degrees. At angle T, you're saying the 60 degrees to P and to A. That's this angle. Now it says find angle ACT. That's as C, the one in the middle, to A and to T. Find this angle. It has been marked. So this is what we're looking for. This is the angle we're looking for, unknown. Now, like said, while solving question 12a, these kind of questions are questions that you might not even be sure how you're going to get the answer. But what you're supposed to do, or what you're meant to do, is to use what you have to get as many data as possible before you can finally solve. Now we have a tangent here. A tangent with a chord. So the tangent to the chord theorem applies here. Now, looking at this question, we have our tangent, and it is well known that when you have a tangent and there's no line from the center of the circle to the tangent, then that theorem about tangent and center of the circle, that's a line from the center of the circle, the theorem doesn't work here. So once we have our tangent, we look for how this tangent might help us solve the question. And what should be in our head now at this point is all theorems related to tangent. And in this year, we've seen a lot of questions, or most of the questions that have to do with circle geometry, having something to do with alternative segment theorem on tangent in circle geometry. That means the angle formed by a chord with a tangent is the same as the angle the chord forms on the circumference of the circle. Now what it's saying is that if this is 44, this angle here is also 44, because TB is a chord and the chord hits the tangent PQ at T, forming an angle. That means this big angle here is 44 degrees. You know, this is the chord and this is the tangent, and the angle the chord forms on the circumference, that's from the two ends of the chord, is the same as the angle the chord forms with the tangent, which is also 44 degrees. And remember, we marked out something that we said this line in the middle, that's TC, divides this angle at T to B to Q into two equal parts. So if this is 44, this is 22, and this is 22. We should note that. Now we know this angle is 44 degrees, but we have to represent it so we can get our marks. So we have it as angle T in the middle to B and to Q. You can see BQ is 44 degrees. That's alternative segment theorem on tangent. So we have that as why this is 44, and we know line TC bisects angle BTQ. That means it divides it into two equal parts. That means this is 22 and this is 22, because the whole angle is 44. Two equal parts, we divide 44 by 2. We know this is 22 and this is 22 degrees. We should mark that out, and we'll be asked to find this. Watch, we are getting some of our angles. Now we know this whole angle is 44. To write this out, so we have angle at T, BTC. You can put the angle sign here, equals the same as angle CTQ. T in the middle, Q, which is 22 degrees. We know this will help us get our full mark. So we know this is 22 degrees, and we can say because TC bisects angle BTQ. Now we know this line divides it into two, so this is 22 and this is 22. At this point, you can solve for C taking into consideration this big triangle. Now we have triangle ATC. We can take this big triangle to find what C is. That we already have this angle to be 44. We don't know this angle here. That's this angle inside here. But we have part of it to be 22. But we can find this other part of the triangle. It will help us solve for this. Although while solving the question, most of the angles were found as we're not really certain which was necessary. So in an exam situation, it's advised that you find as many angles as possible until you find your final answer. That's one way of solving it. So we're looking for this angle now. We're looking for angle T at T to A and B. So we have it as A, T. You can put your angle sign here or you can put it on top of T. Is, this is a straight line. This is a straight line. And part of it is 60 and the other part is 44. So we can find this part here, this angle here. This is angle ATB as 180 minus the addition of this. So let's name this one angle, let's call it A. So we can easily find it. So we know A, that's ATB. We're looking for A. Understand this is a straight line. Looking closely, going from here to here. You've gone 60 here, there's a space here. You completed it with 44, that's 22, and 22, that's 44. That means A plus 60 plus 44 equals 180. That's angle on a straight line. We have it as A plus 60 plus 44 will give you 104 equals 180. A equals 180 minus plus 104 crosses the equals sign, turns to minus 104. A is equals to 180 minus 104 will give you 76 degrees. That means this angle, we can erase this A now. This angle is 76 degrees. That's angle ATB is 76 degrees. Now, considering the triangle ATC, as going this way, this big triangle, we have this angle as 44, we have this as 76, and we have this other part as 22. So to make our work better to understand, we can erase all other ones that are not needed. So we have it as 76, we have this as 22. We figured out the rest. Now this 60 is not needed. This is a triangle now. We have 44 of it. We have 76 plus 22 of it. That's this big angle now is 76 plus 22, which we can say angle ATC. That's angle at T to A and to C. That's ATC is 76 plus 22, which will give us 98 degrees. Now we know this total angle here is 98 degrees. And we have this as 44. Then we can find C. That's ACT. We can find this is a triangle. Considering this triangle, maybe we'll draw for us to understand. That means we have something like this. This is our C, this is our A, and this is our T. We have this to be 44. And we have this angle to be 98. Then we can find angle C. That's sum of angles in the triangle. That's 44 plus 98 plus angle ACT should equal 180. You can say let angle ATC be B. The one we're looking for, this angle here is B. Then we can easily find it. Then we know finding the angle B is B plus 44 plus 98 equals 180, sum of angles in the triangle. Now that we've done that, B plus the addition of 44 and 98 to give you 142 equals 180. Then B equals 180 minus 142. The plus 142 crosses the equals to sign and becomes minus 142. B is equals to 180 minus 142 will give you 38 degrees. So the answer to this question is 38 degrees. That's angle ACT at C, or you can put it as angle ATC in the format in which WAEC gave you the question, is 38 degrees. It's possible that you don't spot this big triangle when solving this question. There's a possibility you would have seen this other triangle here, that's triangle BTC, and you're looking for a way to get B first before you get C. That's a possibility in this question, because it depends on what you see or what you see first in this question. So let's say you're looking for a way to get B first, then when you get B you can get your C. That will still give you the same answer. You have seen that you've gotten at this point that this is 76 degrees. Let's say we have all our points and we know this is 76 degrees. With this 76 and this 44, we get this angle. That's 76 plus 44 minus 180. Since this is a triangle, sum of angles in a triangle, so you add these two together, subtract it from 180, then we get this angle. Then this is a straight line. With that we get this other angle too, minus 180. Whatever we get here is also minus 180. Then with this and this you get 4C. Now let's go on to solve it. So we have this angle, which we can call angle ABT from the triangle ABT. We don't need to show too much working because we're explaining 180 minus the addition of 44 plus 76, which is sum of angles in a triangle. This is a triangle ABT. Then we have two angles of the triangle. The third one we're looking for, you can say this plus this angle we're looking for equals 180. At the end you get 180 minus the addition of the other two angles to get the third angle. So 180 minus 76 plus 44 will give you 120 degrees, which is 180 minus 120 will give you 60 degrees. That means this angle is 60 degrees. Now once we have this angle at 60 degrees, we are looking for this other angle here, which is angle TBC. That's this angle here. And we know this is a straight line. The part of a straight line is 60. So we've traveled 60, the rest will be 180 minus 60, that's 120. You already know it's 120, so we can do it as 180 minus 60, which will give you 120. We can say that's angle on a straight line. Now once we found that this is 120, we take this triangle B to T to C. It depends on how you see the question. This page is to show you that there are several patterns to solving some questions. So we have this as 22, this is 120, we're looking for C. This is a triangle here, if you can see it. BTC, back to B. So we have it as sum of angles in the triangle. This angle we're looking for, let's say, is angle C. That's 22 plus 120 plus C equals 180. That's sum of angles in the triangle. So we have it as C plus 22 plus 120 equals 180. Say sum of angles in the triangle. Now we have C plus 22 plus 120 will give us 142 equals 180. Now we're looking for C. C equals 180 minus 142, because the plus 142 crosses the equals to sign and turns to minus 142. So we have C equals 180 minus 142, we get 38 degrees. Same as the answer we got using the first method. So either way, you still get your 38 degrees and you get your full mark, provided you follow the rules or the theorems guiding circle geometry, and also put in brackets what theorem guides what you're doing. Like at this point, you say sum of angles in a triangle is 180 and the likes, and you get your full mark.